Welcome to Lesson 4 of Day 2 of the Randomizer project lessons. So, today we're going to be reviewing quickly our dice bag runner from the previous lesson with an eye towards adding some more interesting dice to our bag. So, the game of Dungeons and Dragons really introduced the world to what we call polyhedral dice. Polyhedral dice are simply dice with other numbers of sides on them than the standard six-sided die. Of course, the six-sided die is also a polyhedral die, but pictured here are some non-standard dice. Here we have a four-sided die. Here we have an eight-sided die. Here we have a 10-sided die. Here we have my personal favorite, the 12-sided die. And of course, the 20-sided die, where each side is made up of a triangle. These are all polyhedral dice. And we're going to model some of these dice today in our program. So, let's get started. So in Eclipse, last time, we completed our dice bag runner program, which created a bag of six-sided dice that we rolled and calculated the total of. Our dice bag contained 3 dice, and we created an array. That array initially had null values in it, so then we proceeded to instantiate each of our dice as a d6 or six-sided die. And then we proceeded to roll those dice 10 times, outputting the roll number for each roll. Then, for each die within our array, we set the die from the array equal to a temporary local variable called die to make it easier for us to reference. We then randomized the die, and then we took the current total of the dice and we added the current value of the die. And then finally we printed out the die using the overloaded inherited toString method that we inherited from the object class. And then finally we printed out our total. So we'll be coming back to this dice bag runner after we've done some work on our polyhedral die and figured out what we need to do to modify this program so that we can use polyhedral dice. Now, if we were going to create an 8-sided die to add to this die set, we could of course create a D8 class, and it would look a lot like the D6 class. A D8, of course, would be an 8-sided polyhedral die. We would just simply change the name of the class. We would change the number here from a 6 all the way up to here so that it could return 8 instead. However, what we want to do is build in more flexibility. We want to be able to create a polyhedral die where we specify how many sides the die has so that we can create a die with any number of sides at our leisure or our whim. So we're going to instead create a new class that we're going to call PolyhedralDie. To help you spell polyhedral, I'll focus in a little bit on that so you can see it more clearly. That's PolyhedralDie. Okay, and then we're going to click Finish so we get our new class. We're going to add a java.comment that describes what this die will do. So we're going to create a class capable of creating an object that models a polyhedral die with any number of sides. Okay, and as always, we'll go ahead and put our name on the project and include today's date as our version number. Alright, and now we're ready to begin. Now the first thing that we need to remember is we are implementing the randomizer interface. And because we're implementing the randomizer interface, we're going to need to grab all of those methods from our randomizer interface, which are still selected from the last time I visited here. So I'm getting all of the getter and setter methods that I listed in that interface. Then I'm going back to PolyhedralDie, and I'm going to paste those in. Now, because these are just method stubs, they don't have any code, I need to put in some curly braces so that we have some actual code to represent each of those methods. Okay, I'm almost done. Get our last method here. Alright, so now I've got each of my methods listed, and then let's go ahead and put in some comments as placeholders for things that we know we're going to have. We're going to have some instance variables, and we're going to have some constructor methods. Alright, so now we're ready to get to work. Well, the question is, do we know what the possible number of outcomes are going to be? And the answer is we don't know, because it depends on how many sides this die is going to have. And since we don't know how many sides the die is going to have, that should be a clue to us that we're going to need a new variable, a new instance variable that's going to be an integer that represents the number of sides that this die has. Okay, and then just like our 6-sided die, we're also going to want an instance variable to keep track of which side is up. Alrighty, now we're ready to consider what we need to do next. Well, if I knew what the number of sides were, and I wanted to calculate what side should be up, I can do that in the randomize method. So we're going to jump down to the randomize method, and we're going to fill in some code here. So I'm going to say that side up will be equal to, and here I'm going to use my int to cast an expression into an integer. So then the question becomes, what's my expression? Well, I want to take math.random, and I want to multiply that by the number of sides that my die has. Number of sides. And then when I'm done with that, I want to add 1. Because without the plus 1, I would get a number from 0 to 1 minus the number of sides. And if it's a 6-sided die, I want the numbers 1 through 6. If it's an 8-sided die, I want 1 through 8, not 0 through 7. So this expression will give me a nice integer value that is between 1 and number of sides. Now I'm ready to do some work on some other methods. How about get possible outcomes? Can we write that method at this point? Well, how many possible outcomes are there? Of course, there's the number of sides. Possible outcomes. So I'm just going to return the value of that instance variable. And then at this point, can I return the current value? And the answer is yes. I can just return side up. So far, the code here is not very much different than our 6-sided die code. How about getting the current face? Am I able to do that? Well, yes, I can get the current face simply by returning quote, quote, plus side up. That converts side up into a string, allowing me to return the number as a string. Now, what is left to do? Well, I need to build my constructor methods. Now here, we're going to have more than just one constructor, because I'm going to have a constructor where I specify how many sides there are. And then, of course, I should always have a default constructor. So first, I'm going to create my constructor, which is going to simply say public PolyhedralDie, and it's a default constructor, so it has no arguments. I'll label that default constructor. Well, if I ask for a default polyhedral die, what kind of die should I get? Now, of course, we could put anything here, but I'm going to say that if you don't specify, then you probably meant a standard die. and a standard die has 6 sides. The only task left to do is to initialize side up, and I can do that by calling the randomize method. Alright, so far so good, except that the whole point of this was to be able to make a die with something other than just 6 sides. How do I do that? Well, I'm going to do that by creating another constructor method. PolyhedralDie. Only this method is going to take an integer that is going to say set number of sides. Now, can we have two constructors? Well, if this constructor has no arguments and this constructor has one argument, then what we have done is something called, we have overloading. Overloading is when you have more than one method with the same name but different combinations of parameters. So we're going to now write in our code for our overloaded constructor. Okay, so now we're ready to write our constructor. So what do? We say that number of sides is equal to the set number of sides. Oops, I should add an S there. Set number of sides is equal to set number of sides. Set number of sides. There we go. Okay, and then of course, all I'm left to do is to randomize my results. All right, so how do we go ahead and use our polyhedral die in our dice bag runner? Well, we're going to switch back to our dice bag runner, and what we're going to do is we're going to change our array so that our array is capable of storing our new type of die. So we're going to say PolyhedralDie. Oops. And of course, that means that our array needs to be a polyhedral die array. And then we're going to need to construct some polyhedral dice. Okay, and then down here where we created a 6-sided die to hold a temporary reference to one particular die from our array, we also need to change it to polyhedral die. So notice it's highlighted all the places where I've changed D6 to polyhedral die. Now if we were to run our program at this point, we should in fact notice only one change, and that change is that, what did I forget to do? I forgot to overload the toString method. So let's go back to our public toString, back to our class rather, to our polyhedral die, and let's add one more method. We're going to add our not overloaded, overridden inherited toString method from the object class, which looks like public toString, public string toString. And we're now going to return a slightly more complex string, which is going to be return the letter D followed by the get possible outcomes plus an equal sign plus the get current face. Okay, now we're going to be ready to rerun our dice bag runner and hopefully see much more interesting results, or much more user-friendly results. Ah, there we go. Now, why do I see 6-sided die here? I see six-sided die because we called the default constructor with each of these constructors, and therefore I got a six-sided die. But what happens if I change one of these from a six-sided to my personal favorite, a 12-sided die? Let's do that with die 1. And notice here I've got rule number 1, d6 equals 4, d12 equals 7, and of course if this was a six-sided die, a 7 would be impossible, and then a d6, so that my third die is a 3, or a six-sided die. Alright, so let's make our third die, the big boy of polyhedral dice, a 20-sided die. Well, now I have a d6, a d12, and a d20, and then I totaled them. Thus, I have overloaded my default constructor. Here, I'm instantiating a new die in the dice array using the default constructor. You know what? This is not going to fit anymore, so we're just going to move this right above that constructor. And then for the next two lines, we're instantiating two new dice in the dice array using the overloaded constructor. Now, one of the tricks is keeping straight the terms overloaded and overridden. What's the difference between overloaded and overridden? Well, let's switch back to our polyhedral die and review quickly. Here, in my toString method, I have an overridden method. An overridden method is a method that I got from my parent. In other words, the superclass of the class that I have inherited from, which in this case is the object class, and I've replaced it with one of my own making. So I've overridden an inherited method. That's different than overloading a method where I have the same method listed more than once, but with different patterns of parameters. And when I have different patterns of parameters, Java picks which method to call based on which one matches the parameters I used. So in DiceBagRunner, on the first line here, where there are no parameters, I am calling the default constructor. Whereas here, where I've included one integer parameter, I'm calling the overloaded constructor.